Hi guys, in this video I'm going to show you guys how to write the proof for this statement right here. The proof says the product of any two odd integers is odd. So the first thing you want to do when you're writing a proof, or a direct proof specifically, is you want to turn this statement into an if-then statement. So here there are two odd integers, so you're going to introduce two variables. If m is an odd integer and n is an odd integer, then the product of m and n is odd. So now the very first sentence of your proof is the word suppose, and then the if part of the if-then sentence. So suppose m is an odd integer and n is an odd integer. Now we want to define what odd means. We don't have to define what integer means, but we do have to define what odd means. So here I have the definition of odd. So the definition here says n is odd when there exists an integer k such that n equals 2k plus 1. So any number is odd when it could be represented in the form of 2 times some integer plus 1. So you could say, by definition of odd, m equals 2k1 plus 1, where k1 is an element of the set of integers. Again, by definition of odd, n equals 2k2 plus 1, where k2 is an element of the set of integers. Keep in mind that I did put a subscript for k1 and a subscript for k2. This is because k1 and k2 are different variables. If I just put 2k plus 1 and 2k plus 1, then I would imply that these two variables are the same, but they're not. They're not the same. These two variables are not dependent on each other at all. These two variables are different. They're not the same. So you have to indicate that somehow, and I like doing that by putting subscripts. Okay, and then now you want to introduce m times n, so you could say then mn equals, and then you could say, well, we know that 2k1 plus 1 equals m, so 2k1 plus 1 times n, which is 2k2 plus 1, and that equals 4k1k2 plus 2k1 plus 2k2 plus 1. So I just distributed this, and I get 4k1k2 plus 2k1 plus 2k2 plus 1. Here I could factor out a 2, and that would be 2k1 k2 plus k1 plus k2, and I stop there, and then I add the 1 at the end. And we know that 2k1 k2 plus k1 plus k2 is an element of the integers because integers are closed under multiplication and addition. That means if you add integers together, the sum is an integer. If you multiply integers together, the product is an integer. So then you could say, let r equal 2k1 k2 plus k1 plus k2. This means mn equals 2r plus 1, where r is an element of the set of integers, which is the definition of odd. Since remember we defined odd as 2 times some integer plus 1, well here 2r plus 1 means 2 times some integer plus 1. Thus, and then we write the very last part of the if-then sentence, which is thus mn is odd. Keep in mind that you do not need this sentence right here. You could just write this part right over here. You could do that if you wanted to and keep it at that. You don't have to write this sentence, the r variable substitution part. You don't have to do that. I chose to do that because I think it's more clear. I like to say that proof writing is an art. There is no one way to write a proof. People can write proofs in many different ways, and this is one of the ways you can write the proof for this statement up here.